So this lesson is going to be on atomic swaps. So yeah, we're just going to go through like what they are, what they can be used for, where to go for help, building it, executing it, submitting it to the network, and then next week it's going to be covering smart contracts. So what is an atomic swap? Essentially, an atomic swap is it's a way of exchanging two or three or multiple items of value which are represented by tokens on the Hedera Hashgraph. Now, with HBAR, with the Hedera Hashgraph, you're able to do this without a smart contract, just by using kind of native functionality within the software developer kit which we've been using. So yeah, they're realistic, and what I mean by realistic is they facilitate real life situations where in real life we don't just usually give someone something for free. We take something for exchange for it, or vice versa. We don't get something for free. We have to give something in exchange for it. So it allows you the ability to swap one of your own goods for someone else's goods. Now, of course, these goods have to be represented by a token, fungible or non-fungible, or HBAR, whatever. But yeah, obviously you can't do an atomic swap with something that's not on chain. That's impossible unless it's represented as a token on chain. So they're also decentralized, and what I mean by that is there's no central exchange, there's no middleman which is providing the custody, which is transferring the ownership. It is literally peer-to-peer, and it's all been verified by the Hedera Hashgraph. So obviously when you, I don't know, let's say use things like Amazon, obviously you're buying it from Amazon. Amazon then receive the money, and then Amazon give the money to the seller, and they take a fee. Of course, with Amazon you get the benefits of kind of getting their platform to sell it on, but they take a fee. Here there is a little fee, of course. You have to pay for the submission fee, but we'll see how cheap that fee really is when we do it. I mean, it's literally fractions of a cent, so pretty much zero. And they're also customizable. Yeah, you can carefully design them to create very simple exchanges, one thing for another, or you can create quite complex ones where, for example, you have one party sending all of the amount and then 3, 4, 5, 6, up to 10 parties receiving it, essentially. You can also do multiple people pay a little bit and then multiple people receive a little bit, and it's all very, very customizable. So again, this kind of adds to the power of it. Let's say you're buying something from, I don't know, a shop, and they say, oh, we give 20% of our profits to charity. If you were to build this as an atomic swap, you could verify that this charity is receiving 20%, because you can look at the transaction and you can see, right, okay, 80% of it, or let's say the item costs 100 HBAR, 80 HBAR goes to the owner, 20 HBAR is going to the charity's wallet. You can verify it, totally open information. You don't then have to trust the party that they're doing the right thing. So we've already kind of touched upon what they can be used for. I guess it's really sort of any means of transaction. What might have I missed out anything? Anything blindingly obvious? Obviously, like what I've said kind of entails a lot of different things, a lot of different categories. But there's definitely I mean, the thing is with tokens is tokens don't necessarily have to have monetary value. They can have things like voting power or ownership rights. So I suppose with that, yeah, I mean the scope is truly endless. Has anyone got maybe like a cool suggestion?
Yeah, I mean, I'm just interested there, Jake. Can you do like swaps of these domains? So I've bought a HBAR domain, and I'm just wondering, can you do like atomic swaps if you wanted to transfer that to somebody else, or?
You might be able to be honest. That's the domains are something which I haven't looked into too much. Is it tosho.hbar or something?
Yeah.
Yeah, no, actually that's something I need to, honestly, the Oscar and Ada, for those of you who don't know, HBAR, Hedera Hashgraph have just introduced kind of this domain system. And so with that, you can then send HBAR to the domain, right?
Yeah, I tried hooking it up actually in the Hashpack wallet, but I don't know if they've activated the functionality to put in the .hbar address, because it didn't register it. So I'm going to get back onto them just to see when it's going to become active.
Yeah, no, I need to have a further kind of look into this whole, because I see a lot of people, they're charging obviously for the domains now. I reckon it's relatively easy to just make your own domain, and obviously once I can figure that out, then that would be
Yeah,
useful.
when I was talking to Rafa though, he said it's important that you have it, like, even because a lot of scammers on the Ethereum network, they were either like pre emptying somebody minting an ETH
Right.
domain, and then they'd go and they see an upcoming project, they go and steal
Okay.
the domain, and then they go,
Yeah.
oh, send your cash to us,
Yeah, okay. So you kind of have similar to what's happened with all the with the Twitter blue ticks.
Yeah, yeah.
You get people who make up that their XYZ account and buy the subscription.
Yeah.
Yeah, no, that's a good point. It definitely is important to get it in that case, because if somebody owns it, it's kind of, I guess it's even similar with real domains. If, for example, if I own circlestudents.co.uk, I should also probably buy circlestudents.com and circlestudents.org, because it means that no one else can then take it and steal your name.
Yeah, I think that's a good idea.
So yeah, look, I need to. I'm not very clued up on the whole domain thing, but I should be. Right. Yeah. So here's the link to the docs regarding atomic swaps. But it's pretty much going to be stuff that we're covering today. So yeah, let me send you an NFT quickly to you, Oscar. And Ada, were you able to make a NFT in our NFT lesson? I'm not sure. Maybe you didn't. Maybe you weren't there. If you don't have an NFT, I can also send you one. I hope I have enough with. I definitely have enough, but not all of them have images. Yeah. Okay. Right. You're gonna receive an NFT with no image. Okay. That's right. Okay. So Oscar, what you're going to need to do before you can receive this is I'm going to paste in this. I'm going to paste in this token ID. What you need to do is you need to click add token and then paste in the token ID in here so that you can associate yourself to the token. Have you got HBAR as well?
I do not have any HBAR now.
I'll send you some HBAR.
Cheers.
Messages, chat. Right, okay, so I'm going to send you a bit of HBAR. Send you a bit of HBAR. It does not exist. I think you missed a number. 1412802.
One sec. I just copied it from the top, so.
Okay. Oh, that's your testnet account? I think you're on a mainnet account.
Okay.
Does it say? Is there like a big red flag at the top saying you're currently using testnet?
No, there isn't.
Right. Okay. So yeah, you're on a mainnet account. I think we did create a testnet account, so you should have one. If you go over here, change wallet, and then your testnet ones, it will say testnet just below it.
Just have a look. Can you do that again? Sorry.
So on the hamburger icon at the top here, click on that, then change wallet.
It says add wallet, so I don't think I do have one. I don't think I do have a testnet.
Okay. All right. Interesting. Well, if you want to make a testnet one quickly, Oh no, because we used your developer account, didn't we? When we did that thing, yeah. Okay. Well, look, if you want to make a testnet account quickly, then do that, and I'll send it to you once that's done. If not, no stress at all. We can just continue with this.
Right.
But yeah,
Right, no
so
problem. Cool.
I'll set up the code, and the code's very, very straightforward. So to be honest, it's just one document, one file. So yeah, let's go over to our Hashgraph directory. Now we're going to be creating a new file called Atomic Swaps. So new file called Atomic Swap JS. Now the beginning stuff's just going to basically be the same stuff as usual, setting up our client. So yeah, I just went into the send ft function here. This is good because it actually has the transfer transaction, which is what we'll be using today. So yeah, it's got transfer transaction, and I'm going to create a function called async function, and we'll just call it atomic swap. It's not going to take in any arguments. And so we're just going to build a new transaction. So we're going to say, okay, const transaction equals, and then it's going to be a new transfer transaction class. So a new instance of the transfer transaction class. Now, in here, as you can see, there's a lots of different options that we can do. So we can and actually, I'm going to reference the documentation for this just so it's in a kind of neat and more presentable format. How's it going? Are you making a new account, Oscar, or are you just going to save for another time?
I'm just going to save it for another time, just watching through this one.
Fair. So yeah, in the SDK, transactions, and we're looking at this transfer transaction, wherever it is. So yeah, you can basically add an HBAR transfer, you can add a token transfer, you can add an NFT transfer of decimals, approved HBAR transfer. This is something else. This is when you get another party to send HBAR on your behalf. We're not going to be looking at those. But yeah, so these are the ones we're going to be doing, adding an HBAR transfer, and we're going to be adding an NFT transfer. And we're essentially going to be exchanging the NFT in our wallet. We're going to be swapping that with our fee-paying developer account, and they'll be then paying us a bit of HBAR in return.
Sorry, Jake, I was going to ask you there, where exactly is the file stored for the NFT? Is that on the Hedera file service?
No. So this is stored on IPFS, on the interplanetary file system.
Okay, cool.
Yeah. So let's see if I can't get the metadata from here. Although I mean this is pulling the metadata. Let me see. No, so it's not some. So yeah, that's stored on IPFS.
And is that part of Filecoin, is it?
Yes. Yeah.
Oh yeah.
So when we minted the NFT, we passed in this content identifier.
Yeah.
This is a link to IPFS basically.
Oh, okay.
Yeah. So yeah, that's where the metadata stored because it's free. Don't have to pay for anything. So we're going to be adding an NFT transfer first of all. Now, the NFT transfer, it takes in an NFT ID, and all an NFT ID is a combination of the token ID and the serial. So what we can actually do, it doesn't say in the documentation, but what we can actually do is just pass in the token ID and then specify the serial, and that's sufficient for the NFT ID. The next thing we need to pass in is the sender and then the receiver. So Dylan, you're following along, aren't you?
Yeah, I am, yeah.
Right. What I would do quickly is, because we're going to be needing to, because we're sending the NFT from this account, we're sending the NFT from our hashpack account. We're going to need to sign the transaction with this hashpack key.
Okay.
So what I would do is I'd go into your .env file and add your, and I need to do this as well, add your account ID and your private key into this file. So I'll give you a little reminder on how to do that. Firstly, you can find them. You can find the private keys for your account by going into settings. So the hamburger menu at the top, settings, and then you can say view current key phrase. So view, put in your password. And there we go. So this, well, obviously don't show it. But copy the private key. I'm just going to paste it in here. So I'm going to call it the hashpack underscore ID and the hashpack key. Now the key's that. The ID you can find just over here. That's the ID. So we'll paste that in. Now, Oscar, you might not be aware what this .env file is. What this corresponds to is the environment variables. And what it does is, as you can see over here, it basically allows you to use the keys and use private information in a secure way without exposing it to the code. So that's why it's very, very important to have all of your keys, API keys, private keys, etc., in the environment variables file.
So, sorry, Jake, do you mind going back to the .env file for just a sec? Yeah, our hashpack ID. Okay.
It doesn't matter what you call it, as long as you reference it, it's the same thing.
Oh yeah. Okay.
So yeah, I've just called it hashback ID. That's corresponding to the ID, and then hashback key. That's the key. So yeah, what I'm going to do here then is I'm also just going to import those particular values. So I'm going to say the const hashpack ID that equals process.env dot hashpack ID, and similarly the hashpack key, say process.env hashpack underscore key. So now we're basically pulling it from this .env file, and now we've got it in a JavaScript variable. One thing that you need to do is we need to do a similar thing to what we've done over here with the private key, which is wrap it in this private key from string, because at the moment this hashpack key is just a string, while this private key above is a private key. So they're different types. Now we want to have it in this particular private key format in order to begin operating with it in our transfer transaction. So I'm just going to put brackets around it, and I'm going to say private key dot from string. And what this dot from string method does is it takes it from a string and converts it into the correct form. So it's kind of like it does what it sounds. It makes a private key from string. Now, yeah, okay. So with this configured, we're ready to go on to the next step, which is adding the NFT transfer. So we're going to be going over to our hashpack wallet so that we can see what our NFT token ID is. So our NFT token ID can be found here. We've got token ID, and the ID is 0.0.488133351. This is what it is for me. Dylan, yours is going to be slightly different. So make sure you do what yours is. Paste that in there. The first argument will be the token ID. The second argument is going to be the serial. So this is serial number 1. Again, Dylan, yours is probably also serial number 1. Then we're going to be doing the sender account. So the sender is hashpack ID. That's the account which is sending the NFT. And the receiver, well, we're just going to be receiving it with our account ID. So that's the account ID there. So if we were to do this and submit this to the network, presuming we've signed it with the hashback ID, this will be totally fine. However, it means that we won't get anything exchanged for the NFT. So of course, we're going to make it a bit more complex. We're going to add an HBAR transfer, and we're going to have that HBAR transfer coming from the account ID and being sent to the hashback ID. So again, we can reference the documentation, and it tells us here what the method is. So it's add HBAR transfer. Now this takes in two arguments. It takes in the account ID, and it also takes in the value. Now notice how this is slightly different with NFT transfers, because here we don't have to specify the sender or the receiver. We just have to specify an account and a value. Now this is because primarily you can't send, well, it stems from the fact that with token transfers you can send decimals and you can send more than one, whereas with NFT transfers you can only ever send one at a time. So if I wanted to send, for example, 2 NFTs of the same token, I'd have to do the same thing twice. With HBAR transfers and with token transfers, you're able to send half of a token or 500 of a token or 1,000 of a token. And you don't have to specify the sender or the receiver because that's specified in a slightly different way. And we'll go into that now. So basically, I'm going to add an HBAR transfer. Now, the first HBAR transfer is going to be coming from the account ID, and we're going to be sending it to the client. So this account, we're going to be sending it to the hashback ID. This account is going to be sending money, therefore it's going to be a negative value. It's going to let me say 100. Now what we need to make sure is we need to make sure that whoever's receiving the stuff, they receive a total of 100. So again, I'm going to add an HBAR transfer. This one's now going to be for the hashpack ID. And this must receive 100 now. And notice the important thing for this to execute properly is that all of the HBAR transfers, they must add up to 0. Minus 100 plus 100 is 0. Now, this is where we can make things more complex. We can actually say, okay, right, so the account ID is going to send 100. The hashpack ID will receive 75. And a third account, which we'll just say is it's XXX. This doesn't exist, so it will cause an error because it doesn't exist. But that there would have to then receive 25. And again, they all need to add up to 0. So we've got 25 plus 75, 100 minus 100, 0. That's how it becomes JIT. You could even then go a bit further and say, right, actually, I don't want this account to send all of the token. Let's say I want that to send 30, and I want another account, YYY, to send 70. Minus 70, that should be. This will work, presuming we have all of the relevant signatures of the senders. So for example, if we're going to be sending it to 5 different accounts and 5 different accounts are receiving, you don't need to sign with the receiving account. You only need to sign with the account which the token is being debited from. So for example, we'd have to sign with account YYY, we'd have to sign with account ID, and we'd also have to sign with this hashpack ID because they're doing the NFT transfer, they're debiting the NFT transfer. Now, this is where you can then, like I said, build things a bit more complicated. But for now, we'll just keep it simple. And what we'll do is just do 100 for 100. So minus 100, receiving 100. Now what we need to do is we need to freeze the transaction. This is not something we've done before. And that's because we haven't been signing it with keys other than the executing account. So we need to freeze with the client first of all. And this is so that we can then sign the transaction with something other than the account which is submitting to the network. So I've frozen the transaction. Now I'm going to create a new variable which is called the signed transaction. So it's going to be signed with hashpack. And that's going to be equal to await transaction.sign. We're going to be signing it with the hashpack key. So we've basically got this transaction which has been frozen. Frozen means you can't add another HBAR transfer to it. You can't edit it. It's in a fixed state. We have got this particular variable, and now we're signing that with the hashpack key. And now it has, well, it technically doesn't have all of the signatures yet. We still need to have the account ID signature because this account ID is going to be sending 100. But next up, we can just say, okay, now we can execute it and submit it to the network. So we'll just call that submit equals wait signed with hashpack dot execute. We're executing it with the signer, the client, sorry. Now, by executing it with the client, we're then also putting the client signature on the transaction. So that is what allows this here to be done without adding an extra signature. If, for example, our fee-paying account, our client, if our client was an account different to the account sending the money, then we would need to do another line saying sign with said account. But because it's the same account, we don't need to basically sign it twice. Then what we'll do is we'll just get the receipt. So we'll say console log the receipt out, and we'll say, well, first of all we need to get the receipt. So the receipt equals wait submit get receipt, get it with the client. Now we can check the status. So status, then we'll say receipt dot status. And if we run this function, that should be successful. So we've built the transaction, we've built the atomic swap, we've signed it with all of the relevant signatures, we've signed it with the all of the signatures which are being debited with a token, debited from a token, debited a token. So we've got this NFT transfer. The sender is the hashpack ID. So we're then signing it with the hashpack key. We've got an HBAR transfer sending 100. Obviously, therefore, someone has to receive 100. And this sending 100 is being signed by the account ID, which is being signed by the private key over in this line here. So what we're going to do is we're just going to run the code. First of all, make sure you've saved it. And then we're going to say node atomic swap, hit enter. Got status code 2022. So 2022 means success. We can then head over back to our hashpack wallet, and you should see, we go into our history, there we go. And look at, like, this is why HBAR is so good. Look how quick it is. Yeah, we did this literally 24 seconds ago and it's already submitted live to the network. It's just unbelievable speed. So it's an NFT transfer. We've received 100. If we look a bit closer, we can then see where the fees have been sent. So the client account paid 100.025 HBAR. We've received 100. Therefore, the fees are 0.25 now. HBAR to dollars. So 0.025. Yeah, it's so small. It's not even not even coming up as a cent. And this is the same. Like, I mean, we could be sending more HBAR, and we can check that out now. Actually, let's see what happens. Obviously, this. Okay. No. What I'm going to do now is I'm going to change the account. So I'm going to say, right, I'm going to say it's being sent from the account ID, and it's going to the hashpack ID. Because obviously the hashpack ID no longer owns it, so they can't send a token that they don't own. And because of that, we don't need to sign it. But if I let's do 10,000. I don't think I can do 10,000. Let's do 5,000. 5,000. Oh no, let's do 9,000. So you get topped up 10,000 every day. So we should be able to do 9,000 quite easily. I don't think that should cause an error. So I'm going to submit this. No, you don't have to copy this, by the way. This is just me experimenting how much the fees cost. So now I'll close the hashback up at the moment. So there we go. So we've received it. We've got received 9,000 HBAR. It's a bit more expensive this time. Oh no, it's cheaper. Yeah, it's cheaper now. Was it 0. Yeah, okay, mad. So literally, we've just transferred. And again, it's not going to cost us anything. We've just transferred 9,500 US dollars worth, 450 US dollars worth, and it's costed absolutely zero. And you've transferred the ownership. Like, this ownership is can be verified because now it has a new owner. Even things like Polygon, even things like, they're not that cheap, they're not that quick, and this is layer 1 as well. It's not like a quick layer 2, which is technically not on chain until they put it on chain. Go HBAR. Right. Dylan, did you have any success with that?
Yeah, I'm just going to try running it there now.
Nice.
Oh, it's come out for contract function result null.
Can you share your screen, or are you on a different screen?
I'm on a different laptop.
Um,
I'd say it's probably something to do with my .env file.
yes, perhaps. Did you save the .env file?
Yeah, I did. Yeah.
And you've copied these codes over here, yeah?
Yeah, I have.
Right. So just double check that that it's spelt the same. So when you did it, did you copy and paste it over to ensure that it's definitely spelled the same?
Yeah, I'll copy and paste it now.
And if not, I feel like there'll be more. I think there'll be more of an error message as well. So yeah, because I presume the error is quite extensive, right? There's probably a lot on there.
Yeah, it's quite long. All right.
Yeah. So obviously this is probably the secret to coding is knowing where to look in the error message. So what you probably want, is there anywhere saying receipt status error?
No, it's pre-check status error.
Pre-check, and then what goes after that? It says so pre-check status error.
Fail pre-check with status account repeated. Oh, I get it. It's yeah, because I've got my ENV account. Yeah, it's stating my testnet account credentials twice.
Yes, yeah, that would be it.
Okay. But the hashpack private key is different from the private key. Like the account ID is the same, but the private keys are different for the hashpack account.
I think you must have not copy and pasted it from your account ID correctly.
Okay.
So checking your hashpack wallet that you went to settings.
Yeah.
And then you can type in your password. Yeah. So just make sure that it's the right one up here.
Oh yeah, it's definitely the right one up there. It's the private
Okay.
key that's different.
Right, but so what is your account ID?
Yeah.
The same for both?
Yeah, it is. Yeah.
Okay, yeah. So it shouldn't be. There should be two different account IDs.
Oh, okay.
Maybe you copy and pasted. If your hashpack account is correct, then that means it's your account ID which is incorrect. So that's your developer account. You can find that if you just log on to Hedera developer.
I'll try using my other testnet account. I'd say that'll probably work.
Yeah. You could do that. Yeah, as long as, well, you obviously then need to get the private key for it. As long as you'll then also need to. Actually, no, it should be right. Yeah, if you just put it onto your account ID, just replace this here directly, then there won't be any changes needed in this code. Right, I'm gonna just finish off with the final slide. So yeah, I mean that's pretty much the lesson in terms of what I wanted to show you. Just kind of get a glimpse of what you can do with these atomic swaps. It's pretty much how most of the NFT marketplaces on Hedera Hashgraph work. No smart contracts needed, really. Next week we're going to be looking at smart contracts because obviously they do serve a lot of utility. They do serve a lot of functions. So what a smart contract is, creating a smart contract, and yeah, thank you very much.